Ammonia is an extremely valuable inorganic substance used in the fertilizer industry, the manufacture of explosives, and many other applications. The formation of NH3 from N2 and H2 is exothermic, but the reaction is extremely slow at room temperature. To be practical on a large scale, a reaction must occur at an appreciable rate and it must have a high yield of the desired product. In 1905, after testing literally hundreds of compounds at various temperatures and pressures, Fritz Haber discovered that iron plus a few percent of oxides of potassium and aluminum catalyzed the reaction of hydrogen with nitrogen to yield ammonia at about 500 degrees Celsius. This procedure is known as the Haber process. A mixture of nitrogen and hydrogen gas at pressures up to 200 atmospheres is passed over the catalyst at 500 degrees Celsius. In heterogeneous catalysis, the surface of the solid catalyst is usually the site of the reaction. In the first step of the Haber process, H2 and N2 molecules bind to the surface of the catalyst. This interaction weakens the covalent bonds within the molecules and eventually causes the molecules to dissociate. Although the dissociated species are not truly free atoms because they are bonded to the metal surface, they are highly reactive. These highly reactive nitrogen and hydrogen atoms combine to produce the desired NH3 molecule. The ammonia gas produced, along with the unreacted H2 and N2 gas, passes through a series of heat exchangers to cool the gases. The gases then pass through a refrigeration unit and ammonia condenses to a liquid and is collected. Nitrogen and hydrogen have higher boiling points and do not condense. These gases are recycled in order to produce more ammonia. A catalyst is a substance that increases the rate of a chemical reaction without itself being consumed. In many cases, a catalyst increases the rate by lowering the activation energy for the reaction. Let's assume that the following reaction has a certain rate constant, K, and an activation energy, EA. In the presence of a catalyst, however, the rate constant is Kc, which is called the catalytic rate constant. By the definition of a catalyst, the rate catalyzed is greater than the rate uncatalyzed. Note that the total energies of the reactants A and B and those of the products C and D are unaffected by the catalyst. The only difference between the two is a lowering of the activation energy from EA to EA prime. Because the activation energy for the reverse reaction is also lowered, a catalyst enhances the rates of the reverse and forward reactions equally.